So we're now going to plot these on the graph. So we're going to go 0, -1, and then 1, 0. So 1, 0, and then 2, 1, and then 3, 2, and then 4, 3, and 5, 4. Okay, so our next step is to draw a line. Okay, so I'm going to do that. Okay, so this is my line. I've drawn my line and I've extended it throughout the whole grid. Okay, so not just through those coordinates there. Press pause and copy that down, please, or mark your work. So question 3, same thing. We're going to find our values in our table. This is step 1, and then we're going to plot them as step 2, and number 3, join our line together. So 0 is our first x value we're putting in. So 0 times 2, okay, because that's what 2x means. So 0 times 2 is just 0. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. And 5 times 2 is 10. So that's step 1 completed. Now we're going to plot these on our grid. Okay, so we start off with 0, 0. Then we start off with 1, 2. So 1, 2. And then 2, 4. And then 3, 6. And then 4, 8. Okay, I can't plot the 5, 10. I don't have enough room. You can always draw a slightly longer grid if you want to in your books. So now I'm going to draw a line. So here is my line drawn. As you can see, it fills the whole grid, not just the coordinates that I plotted. So the final question here, we've got y equals 3x. So step 1, we're going to fill in our table. So 0 multiplied by 3 is 0. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. And 5 times 3 is 15. Okay. So based on the size of our grid, we're probably only going to be able to plot up to this coordinate here. That shouldn't disadvantage us at all to draw the line. Okay. So we've got 0, 0. We've got 1, 3. We've got 2, 6. And okay, we can't plot that one. Sorry, my apologies. I miscounted. I thought we could go up to 10. So we've only be able to plot those 3, which isn't a problem. So we can still draw a line from there. So I'm going to do that now. So this is my line drawn. And remember what I said, you fully extend the line, not just through your coordinates. Okay, so press pause and mark your work or copy it down. So here is some nice bullet points for you to copy down. Okay, so plotting equations on graphs. If no table of values is given, okay, so the examples I've given you so far, you have been given a table of values. You would draw your own table of values, choosing at least 3 x values. Okay, substitute the x values into the equation to work out the matching y values. Then you would plot the coordinates as we were doing in our step 2. And we would join them with a straight line as we did earlier in our step 3, okay? If a table of values is given, like you have been so far, you use the substitution method as above, or plot the first given coordinate, join them with a straight line, and read off the other values needed to complete the table. Okay, so what I would like you to do is to copy this down in your book, so press pause and do that now, please. Here is another example. Okay, so we're going to draw the line of y equals x minus 2, subtract 2. So step 1, we're going to complete our table of values. Okay, so we're going to do whatever our x value is, take away 2. Okay, so our x value here is negative 3. So negative 3 subtract 2 would be negative 5. Okay, then we're going to do negative 2, take away negative 2, so that's negative 4. Negative 1, take away negative 2, that's negative 3. 0, take away 2 is negative 2. 1 take away 2 would be negative 1. And 2 take away 2 would be 0. And 3 take away 2 would be 1. Okay, so now we're going to plot these on the grid. Okay, so we're going to go negative 3, 1, 2, 3, and down 5, 1, 2, 3, 4, 5. We're going to do negative 2, negative 4, so negative 2, 1, 2, 3, 4. We're going to do negative 1, negative 3, so negative 1 and negative 3. And 0, negative 2, 0, negative 2 is here. And then 1, negative 1, so 1, and then negative 1. And 2, 0, so along the corridor 2, but I'm not going up or down the stairs because my y coordinate is 0. And 3, 1, so along the corridor 3 and up the stairs 1. Okay, so our next step is to draw a line through the points. So let's do that now. So here's my line, and finally we're going to label the line so we can identify our graph. So I'm going to label it just with our equation. So we're going to label the line y equals x take away 2. Okay, so please pause and copy that down. This is your next task, year 8. I would like you to draw the following equations onto a grid. So I've given you an example grid here. So a 10 by 10 by 10 by 10 grid would be useful. If you've got a small squared book, I would just do it as 1 square is 1. And if you've got a big squared book, I would also say 1 squared as 1. Okay, so don't, if you've got a small squared book, don't do 2 squares as 1, just do 1 square as 1 because it can get confusing when drawing the graphs. I know your graphs will be a bit smaller than other people's in your class, but it will more likely make it correct for you. Okay, so press pause, and I would spend around 12 to 13 minutes on this task. So press pause and have a go. Please remember to draw out your table of values before you do each line. You can draw them all on the same grid as long as you label each line as you go. It's absolutely fine. If you don't want to do that, you can draw out separate grids, but I'm more than happy for you to do it all on the same grid. Okay, so spend around 12 to 13 minutes on this task, please, year 8. So here are the answers for that task. What I'm going to do is I don't have a lot of room on my grid, and I'm still getting used to writing with this graphics tablet. I'm going to label each line with the number it was, so 1, 2, 3, 4, 5, 6, or 7. Okay, they are color coded, so that should help, but I'll number them as well. So the black one here is this line here. So number 1 is that line here. Okay, number 2 is this one here. Number 3 is this purpley one here, this one here. Number 4 is this blue one just here, because it's a Y line, so it's going to be a horizontal line, so that's number 4 here. Number 5 is an X line, so these two are similar to our do now. Okay, so this is going to be a vertical line, so it's this green one here. I know it's a little bit difficult to see, but I was running out of color choices. So this is number 5 here, this one here. And number 6 is this quite shallow line here, so that's number 6, this orangey one here. And number 7 finally is this one just here. Okay, so that's number 7 just here. Okay, I'm hoping in year 8 that you can notice something about these lines, that they have different steepnesses, and maybe you'll be able to see in relation to your number that's in front of your x, the coefficient that's in front of x, you can notice that can affect steepness. I'm mentioning this because it's quite useful to know later on when we look at graphs in a little bit more detail. And you might also notice where they cut the y-axis, okay, where the lines cut the y-axis. If we look at number 1, it cuts the y-axis at 3. And if you look at the equation, it's y equals 2x plus 3. If we look at number 2, okay, this line here, where it cuts the y-axis, oh, it cuts it at minus 5. And our equation is y equals 3x, oh, minus 5. Before we even look at this one on the graph, I'm hoping you'll be able to have a little think. And if you look at this plus 6 and have a look at the line, our purpley line here, and it cuts at, oh, it does, yes, plus 6. Okay, we go down to this one here, minus 2. Does it cut at minus 2? Yes, it does, just here. And this one, negative 9. Yes, it does. It cuts at negative 9. So that's something just, you don't need to write that down, but it's just something that is useful to know as we move on. Okay. So now I'm going to have a look at this example exam style with you. Okay, so this is very similar to what would be given in the GCSE. So more likely a foundation paper, but you know, there's no harm in us looking at that. So complete the table of values for y equals 2x plus 3. So they've given you a table of values here. Okay, so they've filled in some of our y values. We need to just fill in the other 3. Okay, so we're going to use substitution to do that. So we'll fill in this one first. I always like to do the positives first before I do the negative. So I'm going to put 1 in my equation. So I'm going to do 2 times 1, which is 2, plus the 3, which is 5. So I'll have 5 in here. I'm going to do the 2, so I'm going to do 2 times 2, which is 4, plus the 3, which is 7. Okay. This one here, I'm going to do negative 2 times 2, which is negative 4, and negative 4 plus the 3 would be negative 1. Okay. So now we're going to do our step 2, which is plotting them on the graph. So here are my coordinates plotted. I've got my minus 2, minus 1. Okay, so that's my x-axis there where the arrow is. So minus 2, minus 1, minus 1, 1. And then I've got my 0, 3, my 1, 5, and my 2, 7. Okay, so my next step is to draw a line for this. So here is my line plotted. Okay, so now I'm going to use that line to answer the next part of the question. So use your graph to find the value of y when x equals negative 1.3. So you might be like, oh, why can't I just substitute that in? You can, but it's saying, particularly here, the important thing to read here is saying use your graph. Okay, because it's saying use your graph, this bit here, that's very important. Because it's saying use your graph to find the values, okay, because it's saying that particular bit, you have to use your graph and show evidence of that, otherwise you don't get marks in these kind of questions. So what we're going to do next is we're going to draw some lines to find this answer here. So what I've done is I've drawn a dotted line. You can see just here. Okay, so I've drawn a dotted line that goes up from my x-axis from minus 1.3. So here, I've drawn a vertical line until I hit my diagonal line, my equation, my line, and then I'm going horizontal to read off what my y value would be. Okay, so my y value, so this is my x-axis here, so we're going up 2 squares here, so it would be 0.2, 0.4. Okay, so that would be my answer. That one there, it would be 0.4. Okay, so let's have a look at the next one. So we're looking now at the value of x when y is 5.5. Okay, so we're going to go to 5.5 and draw a line. So I've gone to 5.4 here, and I've drawn a line that's going horizontal till it touches the diagonal, and then down to the y-axis, x-axis, and then read off that value, and then that value there, to me, looks around 1.1. Okay, so please pause and copy that down.